AIR Search Radar. This is the most common type of military radar, designed to detect and track aircraft at long ranges. Air search radars continuously sweep the sky in all directions, searching for incoming threats. They operate at lower frequencies, which allows them to detect targets at extended ranges, often hundreds of miles away. These are the massive rotating dishes you see at air bases and on ships. Modern air search radars can track dozens or even hundreds of aircraft simultaneously, providing early warning of aerial threats and feeding that information to command centers and weapons systems. Fire control radar. This is the radar that actually locks onto and guides weapons to their targets. Fire control radars operate at higher frequencies than search radars, providing extremely precise tracking data needed to intercept targets. When a pilot says they've been painted or hears a missile warning, it's because a fire control radar has locked onto their aircraft. These radars provide the exact position, speed, altitude, and heading data required to calculate a firing solution. They're found on everything from fighter jets to naval vessels to ground-based air defense systems. Phased array radar. This is one of the most advanced radar types in modern military arsenals. Unlike traditional radars that physically rotate a dish, phased array radars use thousands of small transmitter elements that can electronically steer the radar beam in any direction almost instantaneously. This means they can track multiple targets simultaneously while also searching for new threats, all without any moving parts. The AN-SPY-1 Aegis system on destroyers and the massive AN-FPS-132 early warning radars are prime examples. These systems are incredibly powerful and can track ballistic missiles, satellites, and aircraft across enormous volumes of airspace. Airborne early warning radar. These are the powerful surveillance radars mounted on aircraft like the E-3 Sentry AWACS and E-2 Hawkeye. AEW radars provide a mobile, high-altitude radar platform that can see over terrain and detect low-flying aircraft that ground-based radars would miss due to the curvature of the Earth. The radar dome rotates constantly, scanning a 360-degree area around the aircraft. A single AWACS can monitor airspace across hundreds of miles and coordinate an entire air battle, serving as a flying command and control center that directs fighters to intercepts and warns of incoming threats. Synthetic Aperture Radar. This is the technology that allows aircraft and satellites to create detailed radar images of the ground below, regardless of weather or darkness. SAR systems work by combining multiple radar returns as the platform moves, synthetically creating the effect of a much larger antenna. This produces extremely high-resolution images that can identify individual vehicles, buildings, and even changes in terrain. Military reconnaissance aircraft and spy satellites use SAR to monitor enemy facilities, track troop movements, and create detailed maps of target areas. Unlike optical cameras, SAR can see through clouds, smoke, and at night. Over-the-horizon radar. These are among the most powerful radar systems ever built, capable of detecting aircraft and missiles thousands of miles away. OLTH radars achieve this incredible range by bouncing their signals off the ionosphere, allowing them to see beyond the horizon that limits conventional radars. They operate at very low frequencies and require massive antenna arrays, often spanning several miles. The United States operates several OTHB systems for early warning of bomber and missile attacks. These radars provide strategic warning time that would be impossible with conventional systems. Doppler Radar. This radar technology uses the Doppler effect to measure the velocity of targets by analyzing the frequency shift in reflected radar signals. In military applications, Doppler radar is critical for distinguishing moving targets from stationary background clutter. Modern fighter radars use pulse Doppler technology to detect and track targets even when they're flying against a ground background. This capability revolutionized air-to-air combat, allowing pilots to look down and shoot down enemy aircraft that would previously have been invisible against ground clutter. Counter-battery radar. These specialized radars are designed to detect incoming artillery shells, rockets, and mortars, then calculate their origin point so counterfire can be directed at enemy gun positions. Counter-battery radars track the projectile's trajectory as it arcs through the air and work backward to pinpoint where it was fired from, often within seconds. Modern systems like the AN/TPQ-53 can simultaneously track dozens of incoming rounds while providing precise coordinates for return fire. This technology has become critical for protecting forward operating bases and troop concentrations from indirect fire attacks. Ground surveillance radar. These are specialized radars designed to detect movement on the ground, used primarily for border security, perimeter defense, and battlefield surveillance. Ground surveillance radars are optimized to detect vehicles and personnel moving across terrain while filtering out stationary objects. Modern systems can classify targets by type based on their their radar signature and movement patterns. Some versions are portable, allowing infantry units to set up temporary surveillance coverage. They're particularly valuable at night and in poor visibility conditions when optical surveillance is ineffective. Thanks for watching. Do you think the future of military radar lies in even more powerful traditional systems, or will new technologies like quantum radar and AI-enhanced processing completely transform detection? Let me know your thoughts down below. Also, remember to like and subscribe if you enjoyed this video.